amazing about the physics engine in Unity, especially in the 3D world, is that you can incorporate with it Raycasts. Now in this video, we'll really dive into what Raycasts are and how they can be used and really their power throughout GraalScript 2 and how to enhance your servers and your actual scripts with Raycasts. What is a Raycast? Well, a Raycast is exactly in the name. It's casting an invisible ray and you can do something with it. Now, how does it work? It has three important, let's say, settings or parameters. The first one is the origin point, from where we're actually, well, casting our ray. Next is the direction in where we are casting the ray. And finally is the actual length of the ray. For example, let's say 3 Unity steps away. So an example of a raycast would be starting at this position, going straight down with a length of, say, 2 steps. Now this is a raycast. The cool thing about it is that these raycasts happen in an instant, immediately, and what they do is they can check for collision boxes or colliders with Unity's physics and actually tell us that yes, this raycast has been in contact with a specific collider, or yes, this raycast has been in contact with multiple colliders, and actually return the colliders that were in contact with it. So hopping into GraalScript 2, how we're going to actually implement this raycast is very simple. First, we're going to create our raycast variable, which is a raycast hit. And then, for of course the Unity physics to work, we need to have this dot keep alive set to true. Now let's write how a ray will work, and let's put it in the onUpdate method just for the simplicity and actually having the ray being constant. So while we're doing it, so as you can see right here, it's rather simple. We just created 3 parameters of the raycast, which is direction. In this case, it's the forward of the player. Now, because of how the model is and how the calculation actually works, our model is actually flipped. So we have to multiply it by -1 to actually go forward. The next parameter is the origin, which we're going to start the raycast from the player itself. And then we're going to lower its y a bit just to center it on the actual player. And then we're going to give it a range, a very short range, like a 1.5 Unity steps in front of it. Now what we really want to do right here is we're going to create a continuous raycast. It's going to happen on every single frame, and it's going to check right in front of the player if there is an object. And if there is an object, we're going to just say that, yeah, this object is in front of me. Now you can imagine, for example, having a God mode for the player, and every single object in front of him will be destroyed, or every single object in front of him will start to glow for 2 seconds. Really, this is what the raycast can do. It's going to tell me that, yeah, this object is in front of me. So, to actually do that, we're actually going to use physics.raycast. So, this function basically takes in 4 parameters, which is first the starting position of the raycast, then the direction in which it's going, then the raycast hit that we created, and then the range at which the raycast will be at the maximum. So this will always return false if nothing was hit, and will return true if something was hit. And if something were to be hit, then this dot hit will actually house this object. So we can go this dot hit dot collider dot game object to actually access this game object and just manipulate like any random game object. In this case, just going to take the name and say that, yeah, it's in front of the player. Now if we run this code, yep, as we can see, if I go in front of the letterbox, I can see this letterbox, the physics box of it is right in front of me. If I go towards the hedge, yep, also If I go towards the pole, same thing towards a tree, and basically it works just in front of the player. Now, if I look around, you can see I do not get this. I do not get that the collider is in front of me, which does show the direction of the raycast and its actual power. Now, something really cool. By just slightly editing the code that we just wrote, we can actually change from a single return hit, from just one single object that's been detected, to actually multiple objects that have been detected, all returning at once. Now, the way to do it is first, we don't need a raycast hit create anymore, because what we're going to use will automatically create an array of raycast hits. So we're going to keep the same parameters for now, and we're going to actually write so this dot hit is equal to physics raycast all. Now we want to do a raycast, but we want to return all the actual colliders that we hit, contrary to the actual raycast method that we used before. Now raycast all will just take an origin, where it starts, a direction of the actual raycast, and the range at which the raycast will go. So we do not need this if statement anymore. And now this will actually return an array into this .hits variable, and each element of this array is the same as as the raycast hit variable we had before, the this.hit. So we're going to actually go through the array. We're going to use a for each loop. So for temp.hit in this.hits. So now what we did is we're checking for every single hit. We're just going to create a new player.chat. We're going to just create a new string, basically that is player.chat, and we're going to separate each of the colliders with a double slash, just for display purposes. And it's going to happen once every frame. So now when we hit apply, well, as we can see right here, it's still just one physics object. And the reason is actually pretty simple. It's because a 1.5 range is not enough to cross, for example, the tree into the bin. So if let's say we go for a range of 5 and hit apply, as we can see right here, now I have access to 3 objects, or the 3 physics box, and the dustbin box, because 5 unity tiles away from my actual player, we do have 2 colliders. Now you may ask, where could this actually come really useful? A very simple example, let's get this chair. So if I stop on this chair, my character just sit down and play an animation. Now, a really easy way to actually create that is to create a collider on every single one of the chairs, name it sitting, and just create a raycast downward and check if I am above a sitting collider and I'm not moving, then in that case just play the sitting animation. Well, other examples of raycast can be very simple stuff. For example, you can always shoot a continuous raycast from the camera to the player, and when you get behind an object, right now it's not activated, but you can, for example, make this object dim out or become slightly transparent to always show the player. This would be amazing behind buildings or behind like this pole, just to always have the player in view, but actually tell them that yeah, there's still an object in front of you, there's still a collider, but you can actually see the player. Other examples is to actually be able to use the mouse trigger arraycast in the world and actually interact with the world objects in 3D with your mouse. So take on the previous example. There is a lot in Unity that actually helps with that, especially coming from the actual camera. Now, the way to actually do it is to use specific camera related methods that actually create array directly without actually setting the parameters yourself, just by specifying the position at where you want the array to go. So the best way to create, for example, clicking on actual tiles and returning, actually getting a raycast to see if these tiles have been clicked or not, which tile have been clicked in the world, is rather simple to do. So first things first, we're going to have to set keep alive to true for the events to work. Then we're going to use function on mouse down with the click and only actuate or only do our logic once the left button has been clicked. So if, and now here comes the actual logic. Now, it is actually really simple when you actually look at it. So first, we did initialize our hit variable, the same way we did before. Then we're going with long range because we don't want something really small since we're going from the camera to the world. And here is this magic method. So in the camera class, when we're using cameras, they actually have their own methods. One of them turns a screen point to array. So it goes from the camera, from the center of the camera, towards the screen point to create this direction basically and the origin automatically. This is the array. The only parameter left to give is the range. Now, the point that we chose will be the mouse position from the class input. This is Unity variable updates every time on where the mouse is, basically, which position the mouse is at. So we're going to use the raycast. We're going to give it the ray, which is the one we create right here with the screen point to ray. We're going to place it in this dot hit if it hits, and we're going to give it the range of 100. Now, when we apply this code, as you can see, when I click, I'm actually getting a bush right here, a floor lamp right here, a bin right here, a chair right here. And yeah, right now I have created a way to actually tell which game object I'm clicking on. Now you can imagine how interactive this can be. For example, creating some gameplay with the mouse, or maybe increasing the depth of the code to actually have it holding also the object and drag and drop in it somewhere else. Now, as you can see from here, using Raycast is really powerful because it can create gameplay loops, gameplay checks. It can make everything easier. And don't fret if some method may sound a bit obscure. Everything is present in the documentation. And if you actually try to find online in Unity how to do it, they will explain it in Unity. And just translating it to GraalScript 2 just reverts to checking the same function name or the same variable name inside of and documentation and just writing the same thing in GraalScript 2 to emulate it and actually make it work. It's really simple, really easy, and if you really find any difficulty in it, don't be afraid to just hop on Discord, ask any question you want, and we're more than happy to help you out with it.